Hi everyone. Let's go back to the idea of a set A being a subset of a set B, denoted by this, A, and then this sort of C-looking symbol with a bar underneath, B. A is a subset of B. That means that every element in A is also an element in B. It's assumed that B contains all the elements inside the big circle here, including in this case, all the elements of A. Now, if there are elements in B that are not elements of A, then that means that A and B cannot be equal sets, which means that we can remove the bar there, and we can then say that A is a proper subset of B. So we just need that C symbol there. So every element of A is also an element of B, but they're not equal sets. So now we can talk about the proper subset relationships between these sets. So for example, Z plus, the set of positive integers, 1, 2, 3, 4, 5, 6, 7, and so forth, the set of positive integers is a proper subset of the set of integers. Z, the set of integers, contains Z plus, but also numbers like -1 and 0. In turn, Z is a proper subset of Q. Z is a proper subset of Q because every integer is a rational number. Remember, you can put these guys over 1 and you get a nice fraction. But not every rational number is an integer. 1/2 is a rational number, but it's not an integer. So these are not equal sets, and we have a proper subset relationship here. Likewise, Q is a proper subset of R. Every rational number is a real number, but not all real numbers are rational. Pi, for example, is irrational. The square root of 2 is irrational. Likewise, R is a proper subset of C. All real numbers are complex numbers, but there are imaginary numbers, like I, that are complex but not real. R is a proper subset of C. And there are sets that are even, in a sense, larger than C. Quaternions, octonions, and I'll send an email about that later on. But C is the biggest set we'll deal with in this class. We do nudge a little bit into quaternions a little bit with vectors, but that's later on. Okay. Next up, we're going to talk about set notation. How to parse symbols like these.